I am in search of another planet in the universe where life exists. I can't see this planet with my naked eyes, or even with the most powerful telescopes we currently possess, but I know that it's there. And understanding contradictions that occur in nature will help us find it. On our planet, where there's water, there's life. So we look for planets that orbit at just the right distance from their stars. At this distance, shown in blue on this diagram for stars of different temperatures, planets could be warm enough for water to flow on their surfaces, as lakes and oceans where life might reside. Some astronomers focus their time and energy on finding planets at these distances from their stars. What I do picks up where their job ends. I model the possible climates of exoplanets. And here's why that's important. There are many factors besides distance from its star that control whether a planet can support life. Take the planet Venus. It's named after the Roman goddess of love and beauty because of its benign, ethereal appearance in the sky. But spacecraft measurements revealed a different story. The surface temperature is close to 900 degrees Fahrenheit, 500 Celsius. That's hot enough to melt lead. Its thick atmosphere, not its distance from the sun, is the reason. It causes a greenhouse effect on steroids, trapping heat from the sun and scorching the planet's surface. The reality totally contradicted initial perceptions of this planet. From these lessons from our own solar system, we've learned that a planet's atmosphere is crucial to its climate and potential to host life. We don't know what the atmospheres of these planets are like because the planets are so small and dim compared to their stars, and so far away from us. For example, one of the closest planets that could support surface water, it's called Gliese 667cc. Such a glamorous name, right? Nice phone number for a name. It's 23 light years away. So that's more than 100 trillion miles. Trying to measure the atmospheric composition of an exoplanet passing in front of its host star is hard. It's like trying to see a fruit fly passing in front of a car's headlight. Okay, now imagine that car is 100 trillion miles away, and you want to know the precise color of that fly. So I use computer models to calculate the kind of atmosphere a planet would need to have a suitable climate for water and life. Here's an artist's concept of the planet Kepler-62f, with the Earth for reference. It's 1,200 light years away and just 40% larger than Earth. Our NSF-funded work found that it could be warm enough for open water for many types of atmospheres and orientations of its orbit. So I'd like future telescopes to follow up on this planet to look for signs of life. Ice on a planet's surface is also important for climate. Ice absorbs longer, redder wavelengths of light and reflects shorter, bluer light. That's why the iceberg in this photo looks so blue. The redder light from the sun is absorbed on its way through the ice. Only the blue light makes it all the way to the bottom. Then it gets reflected back up to our eyes, and we see blue ice. My models show that planets orbiting cooler stars could actually be warmer than planets orbiting hotter stars. There's another contradiction. That ice absorbs the longer wavelength light from cooler stars, and that light, that energy, heats the ice. Using climate models to explore how these contradictions can affect planetary climate is vital to the search for life elsewhere. And it's no surprise that this is my specialty. I'm an African-American female astronomer and a classically trained actor who loves to wear makeup and read fashion magazines. So I am uniquely positioned to appreciate contradictions in nature. And how they can inform our search for the next planet where life exists. My organization, Rising Star Girls, teaches astronomy to middle school girls of color using theater, writing, and visual art. That's another contradiction. Science and art don't often go together, but interweaving them can help these girls bring their whole selves to what they learn, and maybe one day join the ranks of astronomers who are full of contradictions and use their backgrounds to discover once and for all that we are truly not alone in the universe. Thank you.